Okay, so back. And we're going to go ahead, and this is a third in our video series for today. Okay, and this shows we've got the definite integrals, and really we're still finding the area under a curve, but we've put it in a most general sense, because what we're really calculating is this. If we've got this function here, the red line there, that's y is equal to 1 over t, that's f of t is equal to 1 over t, right? And what we're really after is this. And written in terms of our definite interval, that area is given by the definite integral summed from a to b of f of t dt, where f of t is the graph of this function here, right? And dt, those are the many little slivers of rectangles that we're dividing that we've divided this area into, that are infinitely thin. Not quite zero, but as close as we, effectively zero. Okay? And in this, by the way, I shouldn't just say a and b. This is now, since a is 1 and b is 2, this is going to be 1 to 2. Right? Now these were written in terms of our sigma notation, right? And on this one, we divided the rectangle into two. And to make a long story short, when we calculated summed the area of those two rectangles, and these, as you can see, by the way, are left side. So we're using f of 1 and f of 1 and 1/2 as the heights of the rectangles. That works out to be 0.83. Now this one, I divided into 10 rectangles. So from 1 up to 10, right? Technically, that's I is equal to, and I is equal to. So this is f of t sub I, f of t sub I, and then delta t, where delta t is now smaller. And then this gave us a closer estimate, which was the where there's less excess area here. So this is much lower, and it turns out that if we added up all 10 of those rectangles, we would get 0.72, okay? Without going into all of the mechanics of it, all right, to write that out. Now, it turns out our calculator, now what if we let the number of, as we said in the previous rectangles, what if we let this, if we said the limit, is I goes from 1 to infinity. That is the number of, the number of rectangles goes, the number of rectangles approaches infinity. That is, gets bigger and bigger and bigger and bigger and bigger, So this is f of t sub I delta t. Then that becomes that, which is the area under this curve here. Now how that works, how we'll calculate that by hand, we'll get at next time maybe. But this time, we're going to show how your calculator will do this mechanically, that is numerically. Okay, so if I'm showing the calculator here, what I want it to do is I want it to evaluate this function here, specifically, and I haven't written the name of the function in. Really, this should be down here. I'll put it in another color here. All right, let's say red. Okay, since f of t is 1 over t, this would be from 1 to 2, 1 over t dt. Okay, we're evaluating that interval, or that integral. We're getting that area right there. Okay, where this is still f of t is equal to 1 over t, right? Now, I'm going to graph, in order to have it evaluated on the calculator, I'm going to have to graph it first, all right? And notice here the window limits, the y value goes up to about 1.5 from 0, and the x value goes to about 2.5. So before I even graph, I'm going to arrow down here. And this is not totally necessary, but we'll get a better picture okay? Especially after I focus this. Okay, I'm going to do 1 divided by x on this calculator, right? Now I'm going to go straight to window, and I'm going to let this, the x min, be about -1, and the y min about 2.5, since we want to go from 0 to 2. And we'll let the x min values, we'll let that be about -0.5 up to about 1.5, again to reflect the values on the graphs we had before. But you can play around with those. Now we graph it, right? And there's, hopefully you can see a picture similar to the one we were just looking at right there, okay? Now, what I wanted to do, maybe I'm going to move this up a little bit. Okay, well, that's about as, okay, I guess that's as good as it's going to get. That's 1, and that's 2. You understand those are limits, and we want this area here, okay, between 1 and 2. So what we do is, once we've graphed it and we've got a nice window, here's the calc part. We're going to do, see up here where it says calc, we want the calc menu, right? And down here, look at choice 7. Oh, that's the one we want. That's the numerical integral, and it will give us the exact area. So I hit enter. All right, now it says lower limit. Now we want it to be, remember we wanted from 1 to 2, so I'm going to arrow over till it says, and that's about pretty close to 1 there, and I hit enter. And then the upper limit, I want that to go to about 2. As close to 2 as I can get it, 1.99, that's pretty good. So that's pretty close to 2. And boom, ooh, it drew the picture, huh? Isn't that cool? All right. So, and then down here it gives the area, which is 0.676. So rounded up, that's about 0.68. So the actual area, so down here in purple, the actual area is 0.68. There we go. The actual area is about 0.68 as calculated by our calculator. Now we do that, how we do that by hand we'll get to later on, but I just want to make sure that we know how to do it on our calculator, okay? Now the most of the homework where it says you're calculating a Riemann sum is going to be what's in the book, very similar to what we did before, okay? So I'm actually going to take this away here, okay? And I'm going to show us the page in the book where we're working, right? And I'll get you started on this. Here is our book page. Okay, in this figure number 1, draw rectangles representing each of the following Riemann sums. Well, doesn't that sound familiar? For the function f on the interval 0 to 8, calculate the value of each sum, right? So this is exactly what we did before, right? And you see here we want 4, so you're going to divide this interval up into 4 intervals. You're going to divide this total interval from 0 to 8 up into 4 intervals and make the rectangles on the left and make the rectangles on the right. And you're going to do the left and the right hand sum with delta t is equal to 2. I'm sorry, 2. Delta t is 4. Sorry, I read that backwards. Delta t is 4. So doing a little arithmetic here, right? Delta t is equal to 4, right? that means we want the interval length to be 4. So that means 8, the total elapsed interval distance from 0 to 8 divided by 4, that means there's going to be 2 intervals, 2 rectangles. So this is the one where there's 2 rectangles. So like the right-hand sum would look like that, wouldn't it? And then the left-hand sum would look like that, right? And then for delta t is equal to 2, that's mean we want the width of the rectangles to be 2. So maybe you can see that it's going to be 0 to 2, 2 to 4, 4 to 6, 6 to 8. Just like that for the left-hand sums. And you're going to use the function values over here. Okay, just read approximately what the function values over on the left for each of the left or right side heights. And that should give you, that'll give you the heights of the rectangles, and then you'll add the rectangles together. So hopefully you can see that that's kind of the same thing as we've just been doing, right? Okay, but now we're calling these Riemann sums. That's what we're doing. Down here, okay, use the figure here to estimate from negative 15 to positive 10. And again, you're going to look at that and you're going to go, oh, okay, I need to go from here and here and here. I need to negative 10 up to positive 15. This says we want the area under the curve from negative 10 up to positive 15. That's, oops, positive 15 is right there, right? So I'm going to leave it to you to we had something like this on our homework the last time. I'm going to leave it to you to divide that interval into an appropriate number of rectangles, right? That would allow you to get a decent estimate, and wouldn't be too hard to get the heights of the rectangles and then add them up. And I'm also going to, you don't have to do 2. You don't have to do a left and you don't have to do a right. You have to pick which one, based on which intervals you decide to pick here. You can decide whether the right side or the left side will give you a better estimate. Okay? Now keep in mind, you can't switch in the middle. You can't have do left rectangles sometimes and right rectangles other times. Okay? All right, so that's our idea here. So that's that. And then number 4 is going to be the same thing. Okay? So and you can use here, notice it's perfectly possible to use the grid here. You shouldn't use very many rectangles. Don't try to use 10, okay? Or don't use too few. Don't use 2, okay? So try to get to, and you might, as a hint, look to see how these this size of the grid here might help you decide that, okay? So that's that, okay? So over here, then you're also going to do, I'm thinking you're going to do 6 and 7. And again, oh, look, they used the table, right? And it's the same thing. They want you to to estimate, because we're still using Riemann sums here. Okay, they want you to estimate the total area between these. So you're going to take these numbers, you're going to plot them, like we did on the previous homework, and it's going to tell you, it says what values of, it's asking you here, what values of n and delta x did you use? In other words, they're asking how many intervals should you use, and how wide is each interval. All right, so you're going to do 6, 7, and 8, doing the same thing, okay? And then, lastly here, I want you to go ahead and practice using your calculator and the numerical calculator over here about how that works, right? And I showed you, you can go back and go over the video again, kind of hit rewind and work through it again. You're going to use your calculator to work these out, Okay? All right, and then, and I think we'll be doing, let's say 9 and 11. Okay? So I'll write which homework problems exactly there are. I'll put those on the assignment. Okay? All right, so that is it for today's lessons. Bye.